Hello and welcome back to While True Learn. Let us see what we will be doing today with our first neural network level, Rosenblatt Perceptron. Learn how to detect the cat in the pictures. Apparently we've done that. Hey, so I've managed to make my computer detect the cat, but that beast is a complicated soul. It definitely has more to tell. Maybe it's time to go next level and start recognizing emotions. Ever heard of perceptrons? They were invented in the 60s to recognize written text. Everyone knows that everything invented in the 60s is awesome by default. The double helix, rock and roll, lava lamps. Well, that's an opinion. Also, you can maybe switch to dogs instead of cats. Decision trees worked like a magic for my Pluto. You can also hit the store and get that random forest node. A forest is more effective than just one tree, you know? Okay, so perceptrons can actually learn and improve. So I feel like we have just leveled up, maybe is the wrong term here. Well, it's the correct term, but not in an RPG sense. We are moving on to another tier of abilities here. If they make a ton of errors along the way, the percentage of errors are shown on this icon. Okay, so use a training mode to teach perceptrons and decrease the amount of errors. So we're going to be starting by making 75% errors. That sounds pretty good, honestly. Whoops, I did not mean to do that. That was my finger twitching, and I clicked through something I wanted to read. Hold on. No. Well, this is awkward. Menu. Reset tutorials. Maybe I won't worry about it. I don't see a load option. I was gonna load my thing. It's okay. Pause the video and read it yourself, I guess. Which I will be doing when I'm done recording here. So 300, 300, 300. We want to sort the shapes. We get one node. And I guess we just do the obvious. Alright, test. Let's see what happens. We ran out of time. Low accuracy result. Okay, I wonder. So a thought I did have while this was going on is that if we're getting it wrong 75% of the time, then that means that we'd be getting it right more than 25% of the time if we just hooked them up to the wrong thing, right? Oh no. So I did get everything up to 9, but I didn't get up to 60. Oh, I'm supposed to be doing training. Stop. So maybe if I had read that thing, it would have been useful. There's nothing more you can teach them. Okay, I mean, if that's all that there is to it... Well, 20% accuracy. Okay, yeah, that one was wrong. Hmm. Well, I guess we just push forward and see what's gonna happen with this, but, I wonder if we're no longer dealing with deterministic puzzles, because before it was giving us a concrete ordering of everything. But if we have random errors being introduced, they might be deterministic as well. It might just be that we've gotten to a point where it's no longer reasonable to track everything and try to get everything to be optimal. Fresh milk at cat.meow. Apparently we're not the only person using that domain provider. Hello, my name is Sam. I own a dairy products factory. My dream is to make the very best goods on the market, and that's impossible without high accuracy and fermentation processes. Alright, off with the fancy words. I want a program that will judge the quality of a product by its ingredients. We often make mistakes when doing it manually, and a lot of our products never leave the factory, since we mark them as defective. We have the data, but we need the algorithm. Sure. Well, we get one of these, and then however many trash cans we want. Oh, I can just click the I and it brings this back up. Okay, well, now let's actually read this. I don't know why. I guess I saw the eye on the trash can and I was like, hey, I could probably click that. And then, yeah, I don't know. In training mode, Perceptron reduces the amount of errors while trying to predict the shape of elements. In test runs, Perceptron only predicts shapes. Rosenblatt's Perceptron used in Mark 1. This Perceptron could recognize only simple linear dependencies, but it was enough to recognize English letters. Okay, cool. Well, we put this here. So anything could go here. But we need circles here. Hold on, can I do training just with this? I mean... I can. Let's just hook this up though. So we want circles to be accurate and everything to go here. I don't think we need the trash. I think the trash should just be given to us by default, although we didn't have it in the previous mission, to be fair. Right, and we can do... previous levels if we want to, but we will just do this. So our tolerance here is 40% errors. Yeah, and once again, we did not get our gold medal. Not really sure what we can do about that. I'm just going to assume that we're not doing anything about it at this point. Maybe like real life, you do not get a perfect result every time. Alright, Metal Gear Construction. Solid Construct with 2 L's. Hello, we are the Metal Gear Construction Factory. We produce fittings and supply raw materials to construction grounds all around the world. We are especially proud of our high standards of quality. At the moment, we're receiving a lot of new orders and we're running late with the deadlines. An algorithm is required that will analyze the quality of raw material and discard poor quality ore before it leaves the conveyor. Manual analysis takes way more time than we can afford. Alright, so... now we do the same thing but with color. No we don't, because the color is a different system. So we don't actually care about the color at all? Well, no, we can, 7 nodes, huh? I think the first thing we want to do is separate out the triangles. And then we go... Well, we have a lot of blue and not a lot of green, so I'm actually gonna do it like this. So the green should go 50-50. Which I could do another sorter here. I mean, okay, I do have... So these green are just going to be slower than the blues, but we can still save all the greens. That's fine. So that handles the triangles. And then with like a 20% error rate, because we'll have the wrong shapes. But then for circles and squares, do we need them going separately? I mean, I guess we're probably just doing the same thing for both of them, right? Where if red go through can I send both of these to the same node? Yes, of course I can. Okay, so since we're just doing the same thing with them, if red, we go through 40 versus 30, so yeah, we're more likely to get blue. But if we get green instead, no, no. So if we get the red, keep going. If we get blue or half of the greens, we throw it out. Then the rest of the greens we throw out, the rest of the reds we push forward. I think this works. I guess I could have used another trash instead of going back, but nothing more can train them. I'm not sure about this whole training thing. This seems kind of arbitrary because it doesn't actually seem to matter yet. Also, there's no silver anymore. Interesting. So with the way that these are set up, yeah, I will be getting some errors here because I got the shapes wrong. Okay. So this is too slow. What that tells me is that I need more tolerance for error. So really what I'm playing with is this error value here, or accuracy, where we're only going to have 60% accuracy. If we get 70%, we're overachieving, and we don't need that. So this is like the real world. Minimum viable product. Okay, so we need... yeah, so this is slowing down because we're doing an extra processing here. Maybe this being the bottleneck is the issue. Maybe I should just scrap this whole thing, actually. Because this is the slow process. If we divide by color first... yeah, let's try that. We'll divide by color first. So if we get red, yeah, we have more blue than green. Green will just kind of be random whatever. But if we get red, we go up this way. And then we are going to assume that we're red, so we're just going to accept both of those. If we're not red, then we want the triangle. All right, let's so this is going to be far lower on the accuracy level. But we are at 20%, so let's just see what happens. Let's see what our final accuracy is. It should be 80, right? Because we're going to have the 20s here. Yeah, around 80%. Okay. So that was faster, but there was probably a better way of doing it. Toy manufacturing. Nuke your toy, yes. Howdy. I'm contacting you on behalf of Nuka Toy Company. We design and manufacture toys for children using 3D printing technology. There are 3 types of raw materials we use for printing, and we need an algorithm that would distribute them correctly. Passing a certain errors threshold could result in a disaster, so watch out for those. Alright, so circles go up here, squares and triangles go here, but also everything goes here. And then we have 2 different inputs with different ratios. So input 1 is higher on circles and lower on squares and triangles. So, oh, we only have, right, no color, of course. So, I mean, we'll just do the obvious, I guess. Start with the obvious, and then if it doesn't work, look for a plan B. So, if we get circles, go up here, otherwise... Well, otherwise go here, right? But I do need all of these. I mean, I could just do this. The thing is, I need 30... Do I need 30 circles, or do I need 30 items with a 70% accuracy? Okay. It will not let me just put the input directly into the output, but I mean, it was gonna solve it. Now I have to put a delay in it. Oh. Okay, well, I mean, because now the issue is I could do this, but now I don't have anything for this output. So let's look at the numbers, I guess. You are the most likely to get a circle, so you going here makes sense. You are the most likely to be getting squares and triangles, so you going here makes sense. So instead of sending the less likely result here, maybe we send the less likely results here. I feel like that was a real-world demonstration as well. Some company hires you to write them a program that does something, and you just send them back the same data set. All right, let's see if this is good enough. No, it's not going to be good enough because I don't have enough circles. Getting wrong data in does increase the number, but we need more circles. Well, we could just not have circles here. That's an option. And then if we need to increase the output, we could always do some things. Yeah, still not gonna work. So we capped on this quite quickly. Yeah, because these are... Well, I mean, we need a bigger output here than here. So why don't we just switch these again? So this is basically the unfiltered solution. We're just taking the circles out. Did we get there in time? No. So balance the outputs, maybe? Putting the more common output there and the less common output here. And we can stack the output 4 more if we want to. Which I'm starting to think I'm going to need to do. Alright, well, we're getting this way too fast, so let's just do that. I could run another one of these. Because now the issue is I might not be getting enough here. Alright, we will run a third. We will run a third one of these. No point in running a trash can on this one. So, circles go here. We do need circles. And then we're going to assume that we don't have any circles at this point. No, what's the point of doing this? Like, we're spending these to sort, and then this is going to be a bottleneck because everything's going to be coming in here, which isn't good. Okay, so I think what we're actually going to do then is circles go down here if we have them still at this point. We are... I'll be honest, with the whole accuracy thing, my interest in this whole system is rapidly declining. Because now I feel like I'm just trying to solve everything via trial and error. I'm not really thinking about it so much anymore. Which maybe there is a way of thinking about it, but this is a very unfortunate second episode where I'm going from super positive about the experience to super negative very, very quickly. So, We'll see, but this might be yet another puzzle game that I drop on episode 2. I seem to have a lot of those lately. Well, we'll give it a little bit more time to see what's going on with it. But like, what I've done here, like... I don't see how this actually improves what I had before anyway. So really, what I should be trying to do here is getting the ratios to work better. It's like maybe this helps balance the ratio better, which it did. Yeah, occupancy was a little bit high up here. So it could have been diverting more of the circles elsewhere. Mama Smith's Pizza made us some money, sure. I guess we can buy something from Cat Bay. Get a haircut? No, we're saved for the Cat Marine. There are more options though. Back propaganda poster. Oh, there's a lot of stuff here. Legally distinct mood poster. That's the other thing. I could be getting better results in everything if I just buy all the best computer stuff, right? Increases sockets processing queue by 3. And increase data transfer speed by 1%. Yeah. Like, just doing those things should give me higher scores, right? So maybe the game just assumes... Okay. Not impressed with that. Gonna open a browser and try to get me to do stuff. But, you know, I'm not gonna be doing that then. We have a tambourine that somehow helps. Well, now that we have a faster... Like, if I go back to toy manufacturing and just run this again. My computer should be slightly faster now, right? Just don't know if it's going to make a difference. But presumably that was a little bit faster. Okay, so interesting that we have two different options here. Let's go for the almost machine learning. Reinforcement learning. Hello, we as a society of peoples who love cats. We wants our cats to has all the best. We wants cats to drive cars with no humans inside. But cats have no hands, cats has paws. Can yous make a car that self-drive? Yours, Dr. Meow Cats, human person. Please excuse our grammar, we are not cats, we are humans, but we can't type well because we has paws and no hands. Terrible car accident, bad surgery, is why we need a self-drive car. Sounds reasonable. Yeah, not a cat. In reinforcement learning tasks, nodes work in a bit different way. Guess a cat wrote this one, too. All data is initially unspecified and your task is to reorganize it and transmit it to the RL agent. Get the unrecognized data on the input and classifies them as either an object or as a road. So hit the objects and drive on the roads, is that, or something like that? Objects go to the upper socket, roads to the bottom. SIFT, Scale Invariant Feature Transform, is one of the most powerful non-neural algorithms for detecting features on pictures, which is essential for image recognition. SIFT is very fast and is capable of recognizing simple objects and patterns. I mean, I like this part of the game a lot, where they're talking about different real-world applications of things. Alright, so I guess this boundary thing is also an obstacle. But there's nothing to do here, right? We just plug everything in and... Of course, we are mostly getting road. And this is 100% accuracy? On the screen, you'll be training and testing your AI. AI acts basing on data you've been recognizing when building your scheme. Okay, the data about surroundings on the road are processed from your scheme to machine learning model. Your car won't be capable of learning and detecting obstacles without it. The goal of this type of task is to make the AI clever enough to be able to reach the target average speed level. So don't hit too many pedestrians. Got it. Press supervised learning and drive your track yourself using WASD or arrow keys to teach the AI. Be careful, the car sees only objects inside LiDAR area, green, and only learns from them. Press supervised learning to proceed. Oh. Launch supervised learning and drive the car manually to record your actions. Pay attention to what your vehicle sees. So we only see the green area. Launch training so the machine learning algorithm will try to reiterate your actions. When the car successfully achieves target speed, run the test. Launch supervised learning to drive your car manually and record your actions. Okay, we had a progress bar here. Sure. So I didn't entirely know what was going on here. But we probably should have gone up and looked at this car as well. You've reached your epic limit, but your model isn't good enough yet. Epic limit has been reset. Try using other data parameters. Alright. Right, so the issue was I wasn't going forward. Because we were trying to hit a speed. And I should be not turning until I see a car. Because if I just see the road... Oh, was I going too fast? Is that what happened? Your model has achieved the target speed, just like that, huh? Press test and enjoy the results. It does seem to stop sharply. Alright, well, I mean, it was a pass. That was more interesting. I like that task. Let's do some text recognition. We are aware that you are able to create a text recognition system based on the Rosenblatt perceptron. We need a similar system that would also be able to distinguish vowels from consonants. This task is simpler, but more accuracy is required. First perceptron, machine neuron, was invented by Frank Rosenblatt in 1957. Frank created Mark I in 1960. Mark I is a perceptron machine that can recognize English letters by their shapes. Alright, so we got a lot of shape data. And I'm trying to draw a connection here between vowels and consonants, but I would say vowels would be circles and consonants are probably squares and triangles. And so this output doesn't really make sense to me here. I guess triangle is, we don't know what that is, we're just gonna ignore that it exists. Alright, so we put this in, and I guess we go circles here, squares here, and we need more output here, so we'll put the triangle down here. And I don't think the training phase adds anything to this. Maybe it adds realism to it, but it's not particularly interesting from a game perspective. Alright, we have succeeded. More money for us. Well, we got self-driving car again. That's the startup. What could go wrong? One does not simply walk into Silicon Valley. Complete the tutorial startup, Mama Smith's Pizza Shack, to gain access to the others. Okay, well, we had this startup. Income's going down. Yeah, let's sell that since we're not allowed to have multiple startups, apparently. Alright, self-driving car. Hi, we're trying to launch our self-driving taxi service, very promising startup, but we have a problem. Our algorithm makes a lot of errors when it tries to recognize traffic lights. As a result, cars sometimes move instead of stopping. We hope you can solve this problem. Code must be working very fast. Oh, we have to invest. Sure. You don't need to train your nodes while working on a startup. They already have the minimum error margin because time is money. Okay, good. And so I get 50, there's no medals here. This is just about spending as little time as possible to save on server costs. Alright, well, I mean... we could do this. Now, is there any reason that we would want more of these? The answer is yes, because here we have a 20% error, and we need higher than 80% accuracy. So what that tells me is that at the very least, we need another sifting, so 20% of our errors. 20% of 20% is 4. So if we just put everything through a second one of these, then that should give us a 96% accuracy in theory, right? However, it's going to be really slow, and I see that the circles and squares are more common than the triangles, so the fact that both circles and squares are going to the same place, these don't cost us, right? I feel like we're going to hit a bottleneck here. Yeah, the data is going to... well, no, because we're always going to be running this first. The fact that we can only put this into one Like, we're just not getting enough triangle data is the issue. Okay. That makes sense. Ah, it looped. Right, so that does make sense. We're not getting enough triangle data because we have so much more. So even though we had a 96% accuracy, the 4% the 4% issue with this much circle and square overwrote the 96 that we were getting on the triangles only. So, I mean, we can just keep chaining these forever, right? 50 times? And I don't think it noticeably slows the process down. I mean, each one, it's longer to get to the end, I guess. But... well, okay, so what we could do here... unless I missed something, though, I don't think there's a cost to having... okay, let's, so was I happy with this part at the bottom? I think so. But let's try to get more triangle data out of this. And out of this, I don't think it matters if we send circles and squares separately. They might as well just go together. So then we go here. If we got a triangle, call it good. But if we get circle and square, filter it again. Yeah, and we might as well do this because, again, our input is all being capped here. So it doesn't matter how many of these, like, the distance from input to output will be extended, but it's not like we're creating a second bottleneck ever, because the bottleneck is here. So we've just added a second filter to try to increase the accuracy of the triangles. We're still not super accurate, though. So... is this just a matter of... kind of do the same thing again, where we're gonna go circle and square goes up here, triangle goes down here. In the meantime, I guess we'll say triangles go here. Because there's no point in putting the triangles back in here. No, okay, let's be more consistent about this. So this is circle square. This is triangle. Is this different than what I had? Because the thing I'm going to do is I'm just going to stick one more of these on these. So let's just see how our accuracy goes. Yeah, not getting a lot of triangles. Okay, so data is not quite accurate enough. Hitting too many pedestrians. So what that means is that we just filter the data one more time. So triangle goes to here. Circle and square goes to here. Circle and square goes out. Triangle goes out. And so that should be 20% more accurate than the previous thing I was doing. Output stream 3 not looking great. So is there something wrong with what I'm doing? Because this approach that I'm doing here, we're taking, so what am I actually doing here? We're taking our triangle data, and then we're saying if it is triangle data, keep going. If it is triangle data, keep going. If it is triangle data, go out. And at every step of this process, if it's not triangle data, okay, since this isn't working, I'm going to try something completely different here. So, what happens if we feed our bad data back like this? So then we go here. This should be good. We go here. This should be good. And then here... like, this is what we want for our output. This is what we want for our output. But we don't know that this is accurate. It's only 80% accurate, which means 20% inaccurate. Well, I'm just gonna keep doing this. Let's test this one. Where we just keep feeding the bad data back in. And this is where we start getting bottlenecks now. Okay, but that seems to have worked. So as long as you only drive the car for 15 minutes at a time, it won't crash. It's not as possible to satisfy all your customers in one day. Users' unfulfilled requests are shown in the red color. You don't have the instruments to solve the problem for this startup, but you'll get some to handle the future ones. Okay. So a number of people didn't do well with that, huh? Well, we did what we could. Yeah, cashed out. Load balancing. That seems like a big thing. Hello, we represent a scientific center. Our current programs are underperforming. Can you parallelize our calculations? To process data, your nodes need computing power, a server. Certain nodes require more than one server. The more servers you use, the more expensive your scheme becomes. This node routes elements to the least overloaded socket. This node requires additional server power. Okay. A load balancer is a device that distributes network or application traffic across a cluster of servers. Load balancing improves responsiveness and increases the availability of applications. Okay, so we have squares, and red squares going to 2 places. I see. So server costs are now 0 because this is like physics in university, where at first year you assume frictionless pulleys. Then you get into second year and it's like, okay, now you have to actually calculate the friction of the pulley. So we had servers just had an upfront cost because we were just kind of glossing over it. But now it's like, no, you have to actually make the choice, and your choice is going to be calculated. Anyway, so what's going on here is, I guess the balancer will be sending it to whichever one has less output. Alright, simple enough. Easy money. Ooh, dictatorship. Exciting. Sales prediction. Christmas shop, huh? Good afternoon. We just bought a stock of trees for the holidays. Friends say that you can calculate the peak demand period for them. Yeah, that's going to be the day before Christmas, when everybody's doing it at the absolute last minute. Maybe for something for a Christmas tree, it'll be a little bit more. Decision tree. I see what's going on here. Okay. So we just got the one. So input is pretty obvious. Then for output, we want green anywhere, but we want some greens here. So one of these must be green. And I guess... So if I do any... Yeah, the thing is I need 100% accuracy. So that means I have to do any here. Because if I allow any random... If I do like red or blue, then the other one will be split 50-50. Or split randomly. I don't know if it's 50-50. So I think it has to be this. And then we had enough data. Send the green here. Alright. Good day. Our group is working on finding an ancient artifact called Tesseract. It's a very unstable element which radiates energy in different specters. We've almost found out how to use its power to benefit humankind, but we need a smart algorithm that will separate and direct the flow of energies correctly. A revolution in energetics is just around the corner, my friend. From Not Loki. Yes, very safe. Okay, so here we have a balancer, decision tree, and trash. And I guess we're using all of them? Maybe not trash. I feel like too many outputs here to worry about that. So... Here we want red and blue down here, green up here. Okay, so I think what we're probably doing here, if I had to guess, is we're balancing it. So the question is whether we balance here or here. Probably this way because we need 4 outputs. So I think we're actually forced to do it this way, assuming that we're using a balancer. Alright, so this one gets green. And... well, we need 100% accuracy. Hold on. No, so we don't get green here then. We get... We have more red than blue. So all green goes up here. Blue will be split 50-50, it's fine. Here, likewise, we'll put red at the bottom. And then green is more than blue, so green up top, with blue going 50-50. Alright, not too bad. New production. The best clothes. Top of the morning to you from Zimiletto Outfits. We're trying to optimize our production lines, and we need a system that would distribute textile by material and send them to respective conveyors in equal amounts. We believe that you could nail this job, so we look forward to hearing back from you. Alright, so same kind of thing, probably. 2 inputs, though. A lot of circles and triangles, not so much on the squares, but we need squares everywhere. Well, okay. These are effectively trash, but we want more trash on the bottom. Interesting. Actually, this is the only one, so we just do not want squares. Alright, well, I feel like that seems pretty obvious. We'll just split it 50-50. This one. So we need 100% accuracy. And this, I mean, by itself, this is enough, isn't it? Like, okay, we do have default server. Like, can I just do this? This is probably really bad. It's super slow, that's the issue. So, like, this, actually it might not even work. Let's mess with that a bit. So, I'm not really happy with this, because I'm just basically saying I don't care about this data at all, and I'm just chucking it everywhere. Okay, well, one improvement we could do is we could do this, because this needs more than this. But I think what we're actually going to do here is we're going to have a balancer going to 2 decision trees. And the reason that we're doing this is that we just need to process this faster. So this should process twice as fast. It'll be more expensive, but it's fine. And then I guess we'll just put both of these down here. Now, if you wanted, yeah. So that was better. However, we could get some triangles in here to speed this up. Or some circles, for that matter. I'm wondering what happens... So this is just for testing now. Did this still split 50-50? It looks like it. Alright, well, not gold, but that's fine. There's probably a better way of dealing with this side of things. But I don't want to continue messing with that at the moment. Alright, we've got our self-driving car thing going on here. Something new available here, new hardware. Cerberus 2000, decrease server costs. Sockets processing queue by 5. I'm not entirely sure what that even means. Does that just mean I have more data? Anyway, that will be it for today. So I guess I wanted to say, because there was that bout of negativity in the middle of this Perceptron. It was just this one task I didn't particularly enjoy. The rest of this was pretty fine towards the end. So, yeah, I guess I'll be happy to... So I'm happy to continue with this going forward. So we'll be doing another episode. I will see you then.